Hello, am I audible?
Yes, sir.
Yes, sir.
In last class, we had started instantaneous velocity, instantaneous term, in which I defined you how to calculate instantaneous velocity, instantaneous acceleration, average velocity. Okay,
Yes, sir.
I'm giving you one more problem. Try to solve. These are some formula related to this instantaneous part. Let me give you some hint. In this expression, we have velocity as x-dependent function. So if you have to calculate acceleration, so for acceleration, we have two different formula. First is this, in which a is equals to dv over dt if velocity is time-dependent function. But if velocity is x-dependent function, then we will use this formula. Since in this problem, we have velocity as x-dependent function, so just use this formula. Is it clear, everyone?
Yes, sir.
Okay, try to solve. Good, Sham. One minute, Akash. Just see how to solve it. Since in this part, we have velocity as x-dependent function. So just differentiate this particular term with respect to x. In this part, 4 is any constant term, and root in terms of exponential can be written as power half. So on differentiating, it will be n x to the power n minus 1. I defined you in last class, if you have any expression x raised to n and you have to differentiate it, it will be n times x to the power n minus 1. Now similarly in this part, you may write this velocity as 4 times x to the power half for this square root. Now on differentiating, 4 will be taken as coefficient, so take it outside. Here we have x raised to n is half. So using this formula, it will be n x to the power n minus 1. On simplifying, you will get 2 in 2 times is equals to 4. So you will get 2 x raised to minus half plus half minus 1. So it will be minus half. It will move to denominator to become positive, and it will be just root of x. Is it clear till this part? Marzia?
Yes, sir. Clear, sir.
Yes, sir.
Now we have calculated dv by dx. Now, according to this rule, if velocity is x-dependent function, so acceleration would be equals to v times dv by dx. So just multiply velocity and dv by dx, you will get acceleration. Try to solve. Put the value of this part and simplify it.
So in order to remove the root, we multiply, we power it by 1 by 2, right?
Root in terms of exponential is just half.
Okay.
Put the value of v, which is 4 root x, and dv over dx as 2 by root x, and simplify it.
Sir, done.
Good, Raza. If you put the value of v, which is 4 root x, times dv by dx, which is 2 by root x. This root x and this root x will cancel out. So you'll get 4 into 2, that will be 8 meter per second square. Is it clear, Akash?
Yes, sir.
Yeah, any doubt?
No doubt, sir.
Okay. Now, since we have velocity is equals to 4 times root x, and in next part, we have to calculate displacement. So according to the rule, velocity is equals to dx over dt. So it will be equals to 4 times root x. Root x in terms of exponential can be written like this. Now, dx is in left hand side and we have x in right hand side. So move this term to left hand side and dt on other side, you will get dx divided by x raised to half is equals to 4 times dt. For integration or differentiation, we have to take each term in exponential numerator part. So it will be in numerator as x raised to minus half times dx is equals to 4 times dt. To get whole part as x, you have to integrate this term as well as this term. I'm defining a formula. If you have x raised to n times dx, so on integration, it will be x raised to n plus 1 divided by n plus 1. Similarly, if you have only dx, so on integrating, it will give you just x. Apply these two rules in this expression, you'll get the answer of displacement. Minashi, any doubt?
No, sir.
Okay, try to solve. Good, Nabila. Should I solve? In this part, we have x raised to minus half. So according to this rule, it will be x raised to minus half plus 1 according to the rule of integration, divide by minus half plus 1 is equals to 4. Here we have dt, so on integration, it will give just t. So on simplifying, you will get minus half plus 1. So there will be 1 in denominator of it. You may write this expression as minus half plus 2 over 2. Take LCM as 2, so it will be minus 1 plus 2. So it will be just plus half. So this exponential will become x raised to plus half divided by this fraction will become plus half is equals to 4 times dt. So this 2 will move to numerator. So it will be 2 times root x is equals to 4 times t. 2 into 2 times becomes 4. Now on squaring both sides, you will get x is equals to 4 times t square as your final displacement. Is it clear?
Yes, sir.
Razan, is it clear?
Yes, sir.
Okay, just write it down. Have you all done till this part?
Yes.
Sir. Yes, sir.
Okay. If t is equals to root of x plus 3, find velocity and acceleration at 2 seconds. First of all, rearrange this expression to keep x on one side and this is the whole term to the other side. Then for velocity, just differentiate displacement with respect to time. So v would be equals to dx over dt, and for acceleration, it will be dv over dt. So in this part, we have given t is equals to root x plus 3. So you may write t is equals to root x plus 3. Move this term to the other side, you will get t minus 3 is equals to root x. Now, squaring both sides, it will become t minus 3 whole square is equals to x. Now, expand this expression on the base of a plus b whole square. So it will be, or a square minus of 2ab plus b square. You will get x is equals to t square minus of 60 plus 9. Now apply these two rules to get velocity and acceleration. Is it clear? Nabila, is it clear?
Yes, sir.
Okay, try to solve.
So is it correct?
In question, I have just asked you to find velocity at t is equals to 2 seconds. Okay, Disham. So find your value at t is equals to 2 seconds. Minashi, just check your calculation.
So we have to substitute the value of t equals to in x equals t square minus 60 plus 9, right?
We have to calculate velocity using this rule and then put the value of t to be 2 seconds.
Okay.
If we differentiate it, Nabila, we have to calculate velocity at t is equals to 2 seconds.
Okay, sir.
Since in this part we have t raised to 2, so on applying the rule of differentiation, it will be n x to the power n minus 1 for this part, minus 6 as coefficient, so take it outside, t raised to 1, so on differentiating, it will be 1 t raised to 1 minus 1, and 9 is any constant term, so its differentiation would be 0. So dx by dt is nothing but velocity, so it will be 2t minus 6. Now in this part, put t is equals to 2 seconds. You'll get velocity at 2 seconds. Itsham,
Yes, sir. Now
is it
understood, sir.
clear?
Yes, sir. I got confused in that. I did not do the differentiation method.
Good, Itsham. Good, Minashi. Good, Akash. Good, Nabila. Mazia, just send your answer. Kia, Khalid, Raza. Afsa, any doubt in this part? Good, Mazia. Good, Raza. If you put the value of t as 2 seconds in this part, you will get 2 into 2 minus 6. So it will be 4 minus 6 as 2 meter per second. Now in the next part, you have to calculate acceleration, for which A is dv over dt. So just differentiate this particular part and put the value of t to be 2 seconds. Ehtisham, just check your calculation.
Yes.
Mazia, check your calculation. We have to differentiate this term. Ehtisham, your first answer is correct. Good, Nabila. Good, Raza. Good, Akash. Good, Kia. Suppose if you differentiate it, dv over dt, we have 2 as coefficient, t raised to 1. So on differentiating, it will be 1t raised to 1 minus 1. 6 is any constant. So on differentiating, it will be 0. Now simplify this. You will get 2. T raised to 0 will be just 1. So it will be 2 only. dv by dt is a. So a will be 2 meters per second square. Is it clear to everyone?
So no need to divide it again by 2. So 2 by 2, no need to do that.
Why you have to divide by 2?
So I thought we just get d differentiation of velocity. So I have to do again for t. So I did 2 by 2, so I got 1.
This is whole as one term,
Yeah.
acceleration.
Okay.
Of some, any doubt? Okay. Now, using this calculus, we have to derive equation of motion. So next is deriving equation of motion using calculus method. In earlier classes, you have defined it in terms of graph or using algebraic term. Let's say first equation is v is equals to u plus at. So it is velocity time relation. So velocity and time will define you acceleration. So let acceleration is dv over dt. Move this t to the other side, you will get a times dt is equals to dv. Since this is dv and we have to get complete as v, so integrate both sides. Now to get this integrated part, we have to define limit. Let's say at t is equals to 0, object will have velocity as u, or let's say initial velocity. At some later time t, it will have velocity as v. So on putting these values in this expression, you will get dv is equals to a being constant, take it outside, times dt integration. So if value of t is 0, so value of velocity would be u. If value of time is t, so velocity would be just v. So this is limit to that particular integration. So this type of integration is called definite integration. Is it clear to this part? Akash, is it clear?
Yes, sir.
Now, dv on integration will give you just v. Limit from u to v is equals to a being constant, take it outside. dt on integrating will give you t. Limit from 0 to t. I'm defining what do you mean by this particular limit using graph. Integration simply defines you area under the graph. So suppose you have a curve like this, in which first limit is this part and next limit is this part. It means you have to calculate area between these two intervals from this point to this point. So how to define it? If you put the value of the function to be a, you will get area from this point to this point, this portion. Now, if you put the value of the function as b, you will get area from this point to this point, from this point to this point. So if you have to calculate area between these two intervals, so you will just subtract these two terms. Is it clear?
Yes, sir.
So in this part, we have to define velocity between any two intervals. So this term is termed as upper limit, and this is called lower limit. Using graph, this will be termed as lower limit, and this will be termed as upper limit. So on integrating, put the value of upper limit in this part, it will be v, and lower limit in this part or in place of that, so it will be u, and there will be subtraction in between them, is equals to a being constant. Put the value of t to be upper limit as t and lower limit 0, and there will be subtraction in between them. So on simplifying, you will get v is equals to u plus a times t as first equation. Is it clear?
Yes, sir.
Nazia, any doubt? Just write it down.
Done, sir.
Have you all done?
Oh, no, sir.
Have you all done? Minashi?
Yes, sir. Done.
Okay. Now, second equation is S is equals to ut plus half at square. This is termed as displacement time relation. Displacement time will define you velocity. So let's say velocity is equals to dx over dt. Now you have to calculate the dx. Move this dt to the other side. It will be v dt is equals to dx. Now in this expression, there is no any component of final velocity v. So just replace this particular term using first equation of motion. So it will become u plus a times t dt is equals to dx. Or you may break it further, so it will be u times dt at dt is equals to dx. Is it clear till this part?
Yes, sir.
Now integrate each term to get final displacement. Now to define this integration, we have to take limit. Let's say at time 0 second. So it will have displacement 0 at some later time t. It will have displacement s. Now put these two limits and this expression, you will get dx is equals to u times dt integration plus a t dt integration. If t is equals to 0, displacement will be 0, and if t is t, displacement will be s. Now on integrating dx, it will become x limit from 0 to s is equals to u dt on integration will be t limit from 0 to t plus a as coefficient. We have t raised to 1. So on integrating, it will be 1 plus 1 divided by 1 plus 1 limit from 0 to t. Now, if we simplify it, put the value of x as s upper limit and x is equals to 0 as lower limit, and there will be negative sign in
It's
between.
t dt, right? So it will be t square. Yeah, so
No,
t
we
plus 1
have
plus.
t raised to 1 in this part. So
Yeah.
according to the rule of integration, if you have x raised to n times dx, so on integrating, it will be n plus 1 divided by n plus 1.
Okay, sir.
Now, suppose if we have only dx, there will be some x raised to 0. As any expression having 0 exponential will be termed as 1, and 1 will be multiplicative factor for each term. So you may write 1 as x raised to 0. So if you apply on this term, this formula, you will get x raised to 0 plus 1 over 0 plus 1. So it will be just x. That's why I have defined dx on integration will be x. Is it clear?
Yes, sir, understood.
Now in this part, u t is upper limit t, lower limit 0, plus a, 1 plus 1 will become 2, t squared, so upper limit, so it will be t raised to 2, lower limit t raised to 0, and negative in between. So on simplifying, you will get s is equals to ut plus half times at squared as your final expression. Is it clear to all of you?
Yes, sir.
Yes, sir.
Khalid, any doubt? Okay, just write it down. Have you all done?
Yes, sir. Done. Done, sir.
Next is third equation of motion, which is v square is equals to u square plus 2 times of s. It will be termed as velocity displacement relation. Now there is no any direct relation using velocity and displacement. So we have to derive this particular term. Let's say acceleration is equals to dv over dt. Now in this expression, there is no any component of time. So we have to somehow remove this particular time. So just multiply and divide this particular expression by dx. Now, If you switch this term to this side and this term to this side, it will become dx over dt times dv over dx. This whole term will become velocity times dv over dx is equals to acceleration. Is it clear?
I did not understand the switching part. How would it be?
Okay, just 1 minute. In this second expression, I've just multiply and divide by dx so that this fraction will remain same, since dx is multiplied and divided to both numerator and denominator. Why I have done this? To remove this particular dt in terms of velocity, since we have to define this third equation in terms of only velocity and displacement. There is no any component of time. That's why. Is it clear?
Yes, sir.
Now, in this part, if you rearrange it, you will get a times dx is equals to b times dv. Now, integrate both sides. Next, we have to take limit for this integration. Let's say at displacement 0, body will have some initial velocity, and at some displacement s, it will attain some final velocity. Now put these two terms in this expression, you will get a times dx integration is equals to v times dv integration. If displacement is 0, so velocity is u. If displacement is s, so velocity is v. Now dx on integration will give you x, limit from 0 to s is equals to, we have v raised to 1. So on integrating, it will be 1 plus 1 divided by 1 plus 1 using the rule of integration, limit from u to v. Now, if you simplify it, you will get, put the value of x to be upper limit as s, x as lower limit 0, and there will be negative sign in between, is equals to 1 plus 1 will be in denominator, or it will be constant v square. If you put the value of v to be upper limit, so it will be v square, lower limit, so it will be u square, and there will be negative sign in between, whole divided by 2. Move this 2 to the other side, it will become 2as is equals to v square minus u square. Move this minus u square to the other side, you will get v square is equals to u square plus 2as. Minashi, is it clear?
Yes, sir. Clear.
Hafsa, any doubt?
Okay.
Okay.
No, just a doubt. How you took u square? Because it's just 1 plus 1, right? So u square, v square. Okay, we can take from there. But u square. How did you get it?
Since if you have, suppose px is equals to 2x square, or simply let's say x square plus x, and if you have to put the value of x as 2, so you will define for each term of x, put the value of 2, so it will be p at 2 is equals to 2 in this part, so it will become square 2 in this part, so it will be just 2. Similarly, in this part, this is your function in which we have to put upper limit as v and lower limit as u, and you have to subtract that. Okay.
Yes, sir.
So if this term would be x squared, so you have to put first upper limit and then lower limit. So if you put the value of x to be v, so it will become v squared. And you put the value of x to be u, so it will become u squared, and there will be a negative sign in between.
Okay, sir. Take it from the upper. Yes.
Have you all done? Akash,
Yes, sir.
have you written?
Yes, sir.
Nabila?
Yes, sir.
Okay. So this is all about non-uniformly accelerated motion. Next is graph. I'm defining you some concept related to this whole physics. In physics, we mainly deal with any problem in three different ways. Suppose if you have a quantity which is related by y by x. So whenever you have numerical value, so just put the formula and you'll get your answer. But if y is any x dependent function, so just use dy by dx to get that quantity. And if there is a graph between y and x, so you will take slope of that particular graph. I'm defining a relation related to this. Let's suppose if you have to calculate velocity. So it is nothing but displacement over time taken. You use this formula when there will be any numerical value related to displacement and time. But if displacement is time dependent function, so you will use dx over dt. And if there is a relation or graph between displacement and time, so just calculate slope of displacement versus time graph. It will define you velocity of that particular body. So for a particular quantity, we may have three different ways of calculating depending upon the problem. Whether it will be in numerical, so just use this formula. Whether it will be along variable term, so just calculus method, or whether it will be in respect of graph, so just use slope method. I'm defining one other way. Suppose other quantity is related by y times x or product of any two terms. So using calculus, it will be integration of those, or using graph, it will define you area under xy graph. Suppose in this part, if you have to calculate displacement, so it will be equals to velocity into time. Now suppose if velocity is time dependent function, so you will use v times dt to get this displacement. And next, if there is graph in between velocity and time, so just calculate area under velocity time graph. Is it clear to this part? So in this whole physics, we mainly define any problem by three different ways. First, if there is numerical, so we use formula related to this. If there is variable function or time dependent term, we will use calculus. Or if there is graph, we use this method. Mazia, is it clear?
Yes, sir.
Okay, just write this rule. Have you all done?
Yes, sir.
Minashi?
Yes, sir. Done.
Now, next is graph. In graph, mainly define two terms. First is slope and second is area. Let's say if you have a line from this point to this point, having coordinate x1, y1 and coordinate x2, y2. So draw a vertical line to this and a horizontal line to this point. So this will define you x1 from this point to this point and x2 from this point to this point. Similarly, y1 will be from this point to this point and y2 will be from this point to this point. So if you subtract these two terms, you will get x2 minus x1. And if you subtract these two terms, you will get y2 minus y1. Now, for this particular triangle, we have base perpendicular. So using these two terms, we will easily calculate this theta or slope of this particular graph. So slope is nothing but tan theta represented by m, which is equals to ratio of perpendicular and base. So in this particular triangle, perpendicular is y2 minus y1 and base is x2 minus x1. So using this, you will be able to calculate slope of this particular line. Is it clear? Raza, is it clear?
Yes, sir.
Kia, any doubt? Now, suppose if you have any curve for which if you have to calculate slope. So for any curve, it will be based on variable function. So we can't calculate slope using this. So to define slope for any curve, just draw tangent to that particular point of contact. Let's say this point. Similarly, if you draw tangent to this point, if you define its inclination, so it will be slope of curve at this particular instant. Similarly, if you define its inclination, so it will be slope of the curve at this instant. Now, using calculus, dy over dx will define you tan theta, or it will be tangent to the curve at that instant. So whenever you have to calculate slope related to any curve, just draw tangent at that particular point and define the inclination of tangent with respect to x-axis. So just remember, inclination or theta must be calculated in anti-clockwise from positive x-axis. Is it clear to everyone? Nabila, is it clear?
Yes, sir.
Okay, just write it down. Have you all done?
1 minute, sir.
Done, sir.
Done, sir.
Mazia, any doubt?
No, sir.
Next is to define area under any graph. Suppose This particular diagram is called as trapezium. So for which coordinate would be y1, y2, x1, and x2. This line and this line will be parallel. So if you have to calculate area of trapezium, so it will be half sum of parallel sides
Into height.
into perpendicular separation between them.
Yes, sir.
Or it will be height. So in this part, we have half parallel sides is y1 plus y2, and perpendicular separation will be this part. So it will be x2 minus x1. Now, whenever you have any curve figure, whether it will be circle, ellipse, or any term, suppose this. So you have to calculate area of this particular graph. So take this coordinate and this coordinate. This part will define you its diameter. So let's say x1 and x2. Similarly, if you draw so this will define you y1 and y2. So this will again define diameter along opposite axis. So whenever you have any curve figure, circle, ellipse, or anything, its area will be pi r1 into r2, in which r1 will be along x-axis. So it will be x2 minus x1 divided by 2. And similarly, I2 would be equals to y2 minus y1 divided by 2. So on putting these values in this expression, you will get area of this particular curve. Is it clear? Akash?
Yes, sir. Clear, sir.
Okay, just write it down. Have you all done?
Done, sir.
Raza?
Yes, sir.
Okay. I'm defining you some relation, how you can recognize any graph related to any function. Suppose if you have y is equals to any constant term, so it will define you. It will be a line parallel to x-axis and passing through that constant. Suppose this is y-axis, this is x-axis, and you have to draw y is equals to 2. So it will be a line parallel to x-axis and passing through that particular point, like this. Next, if y is proportional to x, it means both having one exponential or one power. So it will define you linear graph or straight line. So it will be, or the general equation for this particular term will be y is equals to mx plus c. In this, m will define slope or tan theta, and c will define cut on y-axis. I'm giving you one example related to this. Suppose this is y-axis and this is x-axis. And let's say there is a line like this. Since this particular line is cutting y-axis at this point, which is above origin, so you will say C will be positive, and the inclination of this line with respect to positive x-axis is from this point to this point. So it will be some obtuse angle for which tan theta will be negative. So you will say slope will be negative. Is it clear? So
So
using
now will be negative m is upright, theta.
if slope will be negative, it means theta will be obtuse or it will be greater than 90 degree. Let's
Okay,
say
okay, sir. Yes,
if you
sir.
draw a vertical line to this, so this will be 90 degree and this whole theta is greater than 90 degree. So you will say it will be obtuse angle, and for obtuse angle tan theta will be negative. Is it clear to everyone?
Yes, sir.
Okay, just write it down.
Done, sir.
So just a minute.
Okay.
Done, sir.
Akash, done?
So 1 second, sir. Yes, sir. Done, sir.
Hafsa, any doubt to this? Minashi, any doubt?
No, sir, no doubt.
Okay. Next is, if we have y is proportional to x squared, it means this having linear exponential and this having even exponential. So just remember, even power of x, it will be symmetrical curve on y-axis or vice versa. Since in this expression we have only one even term, so it will define parabolic curve or parabola. So the graph of this expression will be like, since in this term we have x raised to 2, so parabola will be along opposite axis. So it will be like this. This curve is called parabola. Now, suppose if you have x square over a square, y square over b square is equals to 1. In this part, we have even expression or even exponential for both x and y. So it will define you symmetrical graph on both x as well as y. And since this particular term having different coefficient, so it will define you this is called elliptical curve or ellipse. From this point to this point is termed as A, and from this point to this point is termed as B. This is Y and this is X. Now suppose A and B are equal, which is equals to R. So this expression will become x squared plus y squared is equals to r squared. It means if A and B becomes equal, so this will be termed as circle, like this. And one last expression, if y is inversely proportional to x raised to n, where n is any number greater than 1, so graph of this particular expression is called rectangular hyperbola, or it will be like this. Y, x, and this will be circle. Is it clear till this part?
Yes, sir.
Okay, just write it down.
Done, sir.
So can you move it a little down? Thank you, sir.
Are you all done?
Yes, sir.
Done.
Now, using these graph, we have to define two terms. First is called slope. Distance versus time graph. So slope of distance versus time will define you speed. Similarly, displacement versus time will define you velocity. Speed versus time and acceleration. Velocity versus time. Both slope will be termed as acceleration. Next is area under graph. First is acceleration versus time. So it will be velocity. And if acceleration versus time mod, it means positive value only. So it will be termed as speed. Next is velocity versus time. So it will define you displacement. Velocity versus time mod or speed versus time. These two terms will define you distance. Is it clear till this part?
Yes, sir.
Just write it down. So now, please wait for a minute.
Okay, sir.
Have you all done?
Yes, sir.
Akash? Treza?
Yes, sir.
Okay. I'm giving you a problem related to this. This is velocity versus time. Let's say this is A, B, C, D. Find acceleration. First, AB, and second, BC. Find distance. T is equals to 0 to T is equals to 12 seconds. Try to solve. Since in this part we have velocity versus time graph. So if you have to calculate acceleration, just see this term, velocity versus time or slope of velocity versus time will define you acceleration. So if you have to calculate acceleration of this particular line, which is just a straight line, so how to calculate slope of any straight line? Try to define coordinate of each point. Let's say for this A, it will be 0 and 10. And for B, it will be 8 and 20. Now, slope is equals to y2 minus y1 divided by x2 minus x1. Put the value of each term, you will get slope of AB. Is it clear?
Yes, sir.
Yes, sir. So it's 5 by 4.
Yes, I think. Try to define the next slope between BC.
Yes, sir.
Coordinate of this C will be 10 and 0. Since this line is going along this path, so it will be along this path. So this will be termed as x2 by 2, and this will be termed as x1 by 1 for BC. Let's say for AB, from this point to this point, y2 will be 20 and y1 will be 10. Divide by x2 will be 8 and x1 will be 0. So 20 minus 10 will be 10, 8 minus 0 will be 8. So it will be 5 by 4, and slope of velocity time graph will be nothing but acceleration. So it will be meter per second squared. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes.
Let us try to calculate slope of BC using the same formula. Raza, just check your calculation. There is some error in sign. Minashi, your answer is correct. Etisham, your answer is correct. Good, Raza. Akash, just check your sign. For BC, coordinate of C will be taken as x2 by 2, and coordinate of B will be x1 by 1. So it will be y2 minus y1 divided by x2 minus x1. So it will be minus 20 by 2 or minus of 10 meter per second squared. Is it clear to everyone?
Yes, sir.
Nabila, is it clear?
So why isn't it 20 minus minus 10? Because the slope BC is, no, I'm sorry, that's BD. It's clear,
No,
sir.
no, since this particular graph is going from B to C, so you have to take this particular term as final point and this particular term as initial point.
Okay, sir.
The next part for calculation of distance from 0 seconds to 12 seconds, you have to take area under this whole graph. This will be your homework. In the next class,